Okay, in this video, what I'm going to do is I'm going to introduce you to using Google Sheets, which is on drive.google.com, to do the first table of calculations for the kinetics experiment. So by now you've done the experiment, you've got the data. Of course, you probably pooled the data with other students, so you're using classroom data. We're not going to get into the numbers of the times yet. That'll be in a later table. But I'm going to begin with table one. So let's start here. We're doing part one, which is the effective concentration. Okay. So in part one, when you read through it, it's going to tell you what the initial concentrations, or I'm sorry, what the stock concentrations on the bottles were of the reagents that you used. And there are four reagents for which we're concerned about their concentrations that we'll look at in this particular calculation set. Okay, so I've written down from the lab manual. These are the numbers from the lab manual, the concentrations of the reagents for potassium iodide, hydrochloric acid, hydrogen peroxide, and then sodium thiosulfate. That's the name of it, Na2S2O3. Okay. Now, below that, what I've done is I've just created a sheet here. This is in Google Sheets. Chart one. So again, this is directly out of your lab manual. Chart one gives you the volumes of the reagents for each experiment. These are in milliliters, okay? So for experiment one, the amount of water we used was 425 milliliters. The amount of hydrochloric acid was 10 milliliters. Potassium iodide was 10, starch and so forth and so on. So those are our volumes. So those are copied directly out of that. Now, what I've also done is I've written up here table one, which is initial moles. So this is your first table that you'll be doing calculations for. And so the way we're going to do this is we're going to do these calculations here. So the first column here is the experiment number. The second column is the concentration of Ki. So that's this number right up here, right? It's one molar. It's actually 1.0, but we'll just write it as 1.0 and then it'll display it as 1. Okay. Now notice that that's the same every time, right? You're adding the same reagent from the stock solution every time, and that concentration of that stock solution is 1 molar. So what I did was I just clicked on the first cell, and there's a little dot down here, and then I just went ahead and highlighted all the way down, and then it automatically puts that in there, okay? That saves some time from just actually entering in the same number every time. Now, what does change is the volume of Ki. So if you look at the volume of Ki, that's right here, 10, 20, 30, it's changing, and then it stays the same 30 and 30, okay? Now, the difference here, the significance of this is that this is in milliliters, right? When we measure volumes in the laboratory, we generally do it in milliliters. But for calculations of moles, we want to have it in liters. So we need to convert that to liters. So here's what I'm going to do. I'm going to hit equal sign in this first cell, and then I'm going to click on the first Ki volume, right? And then to convert it to liters, from milliliters to liters, I have to divide it by 1,000, right? So I'm just going to hit slash 1,000, and that's going to divide it by 1,000. Okay. Now, in fact, Google Sheets is smart enough to recognize that probably what I want to do, there's a good chance I just want to go down and do the same calculation with these other volumes right here. And in fact, I do. So I'm just going to do, actually, I would just hit suggested autofill. Okay. Now, suppose I didn't want to do that, but then I decide, oh yeah, I really do want to do that. Again, you can just click over here and then check. It's always a good idea when you have a spreadsheet program do that sort of filling, just to make sure that it did the right thing, because sometimes you get the wrong cells. These are all cells, right? So 30 should give me 0.03, right? 30 divided by 1,000 is 0.03. So it looks like it did all those right. Okay. Now, how do we find moles? Moles comes from the calculation of molarity and volume in liters, right? In fact, I can say right here, moles equals molarity times liters, right? XL. right? That's the notation molarity. That's the notation for liters, right? So what I'll do then is I'll just say, okay, we need the molarity, which is right here. We need to multiply that by the liter. So times, that's the asterisk, which is option A or shift 8. And then we're going to get the volume. The volume's right here. Okay. Hit return. And then again, same thing. It's just going to say, oh, do we really want to do that multiplication? Yes, we do. Now notice the moles is actually the numbers, the values of the moles is equal to the same as the volume. And that's because the molarity is 1, right? So you're multiplying by 1 each time. Okay. Now let's do the same thing for the sodium thiosulfate. So I'm going to hit equal sign. Oops, we don't have to hit equal sign there because we're just going to take the molarity. The molarity of sodium thiosulfate is right here, 0.04, right? See it right there, 0.04? So I'm going to hit 0.04. And then same thing, I'm just going to fill that down. Okay, so concentration. The liters, again, you got to divide the volume by 1,000. So equal sign, Na2S2O3, there's your volume, 25 divided by 1,000. Okay, and then same thing, let's just go ahead and put all the way down. Notice the volume of sodium thiosulfate is the same every time, 25 ml, so your volume should always be the same. And then moles is molarity, right? Molarity times, so asterisk volume in liters. Okay. All right. And then we got one more to do, which is the concentration of H2O2. So concentration of H2O2 is up here it is, right? 0.2. So 0.2. It's 0.20 actually. Come all the way down. Volume is of H2O2 is right here, but we got to divide it by 1,000. Okay, autofill. And then moles is molarity times volume. And again, we're going to autofill. Okay. So everybody should get, well, everybody should get the same numbers for this laboratory report because you're all sharing data. But definitely you should get the same values. So you can check with your partners, make sure you're getting the same values. You're going to do these calculations on your own and put them in your own report sheets. But there we go. Now I notice when you fill down, sometimes it gets rid of the formatting. It's good to make these as pretty as you can, to be honest with you, because the prettier you make it, the nicer it is. It's like organization skills, right? You just want to have things organized. Okay. So that's table 1, initial moles.